Dear students, I welcome you all for the online platform to learn the course Warehousing Automation. So far we have been dealing with series of lectures with respect to this topic, and in Unit 1 this is what the contents. These all are the chapters available in Unit 1, and till now we have finished 8 chapters, and today we'll go with the ninth chapter, conveyor systems. Still we are left out with one more chapter which has got two things: picking and packing robots and layouts. So with that we'll be finishing Unit 1. So now we'll get into conveyor systems. So inbound logistics is, it is from the supplier end, and outbound logistics is with respect to the customer. So now our core focus is on intra logistics, that is within the warehouse. Within the warehouse, what sort of movements do we make is our discussions, and as a part of it, now we will learn about the next material handling system, that is conveyor systems. So earlier we discussed about two types of conveyor, that is two types of material handling device. The first was with respect to carousels, and the second was with respect to shuttles and cranes. So shuttles and cranes are more or less, they are correlated, and carousel was entirely different. It was entirely different mechanism. We discussed about the types, the benefits, the functionality for all these three cases we discussed in the earlier series of presentation. So now we'll get into conveyors. Now the essence of conveyors is very simple. It is for the case of transportation for a longer facility, throughout the facility for a little bit on the higher end, not like the earlier case. Earlier cases with respect to a small distance, but here it is going to be on a higher end. And this particular conveyor system can be operated differently. That is, we can manually operate, or even we can use simple gravitational force to do it, or by means of a motor. So there are different types are there, and conveyors are the one which literally transforms easy transportation, as well it can minimize the error. So here the accuracy is not a big concern. Why? Because conveyors are not designed for accurate transportation, not from exactly from one point to another point, something like a robot based. No, it is not so. It is from one region to another region. The only essence is the product should be traveled in a very safer speed without any sort of damage. So that is what the objective is all about. Therefore this objective can be easily met just by going ahead with simple modification or simple adaptation based on the nature of the product. They play a very crucial role. Conveyors play a very crucial role in modern warehousing. Why? Because they are the easiest mechanism for the case of material movement. So material can be moved all along the length of the warehouse in a very easiest case. So we can reduce the manual labor, and the main thing is we can improve the operational efficiency without, I stress it, without compromising the safety and accuracy. So warehousing system automation, there are several types of material handling is there, but conveyors are the best, easiest, as well as effective way of using. Now we'll get into the benefits, then we'll see the functionality. The first benefit is speedy delivery, because it is not so complex in design. It is very simple in design. It is specially designed for a longer distance. Only thing is we need to place the product in the conveyor properly, not at the end of the or at the edge of the conveyor. It should have been positioned properly in the center. Of course, guide rails can be designed on the either end of the conveyor so that the product do not fall at any point of time, and easily it is going to be transported. So here we are going to overcome the manual power, where man need not to lift from one end of the warehouse to the packing or the picking portion at another or some other point of the warehouse. So conveyors will take care of all these things. The another interesting feature is, this is what we are supposed to. Earlier during ADC, that is automatic data capture technique, we just discussed powerless, that is passive type, powerless sensors based activities, that is RFID or QR code or barcode, where power is not essential, that is simple stickers will solve the purpose. Likewise here, Power is not essential. Gravitational force, using gravitational force, we can get the things done. So that is the interesting feature in a conveyor system. So just by means of gravity, we can go ahead. Why gravity? Means it is cheap, it is freely abundant in nature, it is something renewable which is always available 24/7. We need not to do any sort of extra inputs or something extra motors, nothing. So gravity will take care. So that is one of the beautiest part of a conveyor system. The next, minimized risk. So here what is the reason for minimized risk is, once the conveyor is properly installed, whatever may be the nature of conveyor we go ahead with, if it is properly nicely installed without any shakiness, then obviously the safety is damn sure ensured. Why? Because it is not going to allow the component to fall somewhere in travel. In due course, it is not going to fall. Why? Because even we can have guide rail. So within the guide rail, the component is going to nicely, it is going to be transported within the conveyor width. So therefore, safety is ensured. And different types of products it can go ahead with, but only thing is we are not supposed to stack, not the one above the other. On the horizontal case, in a series way, one after the other it is possible, but not one above the other. So what happens is, because of the earlier two reasons, that is speedy delivery followed by safety, so obviously both this contribute for increased productivity. On a safer scale, the component is going to be nicely transported from one point to another point. As well, we are going to get the product in a very safe manner. There is no damage. Even the product is delicate, something of glass or something which is highly prone, which is highly susceptible for damage, means even then the component can be nicely transported from one point to another point without any sort of damage. Now there might be another question: who will load onto the conveyor and who will unload? Maybe it can be done by means of robot. That's what our next topic is: picking and packing robot. But all the case that do not mean that we need to have robots. Even a simple man, he can just take from GTP based from a rack and he can just position it onto the conveyor. Even that also will solve the purpose. Rather than lifting the product from one end to the another, he can just position it onto the conveyor. Therefore, it becomes easy for transportation. Now, this is very crucial aspect. See, we go to a textile shop, a ready-made shop indeed. We wanted to select shirt. So we have got splendid options, right from material, what type of material you want the shirt to be, what type of sleeve, either full sleeve or it need to be something like half sleeve, then what type of nature of the shirt, that is plain shirt or some sort of checked shirt or strips, whatever the thing we wanted. So purely it is based on the economy, that is the money what we are ready to spend onto it. Then the nature of fit, of course today it plays a very crucial role. Tailored fit or denim fit, there are different types of fit, slim fit, something like that. So based on the usage, we wanted to be professional, means obviously we don't prefer slim fit. Okay, we go for some tailored fit or regular fit. So likewise, based on the application, even we select a simple shirt. For the case of a shirt example itself, we have got these many parameters. So likewise, on what basis, again I state, on what basis a conveyor has to be selected. So this is very essential. So now the first thing is, some cases, if we select a wrong conveyor in a properly working warehouse, it is going to completely spoil the functioning of the warehouse. Why? Because it is not essential. It should not overpower as well as it should not underperform. So both these cases has to be taken, because it is directly correlated to the fund what we dedicate onto it. In short, investment. Now, accidents. Yes, this is what very important. See, at any point of time, safety can never be compromised, followed by quality. Either of these things should never be compromised, but the priority is always given for safety. So for the case of safety, we should have a proper conveyor. So we need to understand what is the movement of the product essential inside the warehouse. What is the nature of movement has to be thoroughly understood, and based on that only we are supposed to select the conveyor. Now, first, what all are the criteria? So we'll see one by one. Criterion one by one we'll see. First criterion is stock item. The first understanding is what is the nature of the product what you go ahead with. If you want to transport fragile items, appropriate conveyor has to be chosen. You can't prefer a roller conveyor. Of course, we'll discuss the types. You can't prefer unsafe conveyors for a fragile item. Why do I use the term unsafe? Means for a fragile component, we should go for some soft conveyors. The material should be highly soft so that it can transport in a very easier case. So that has to be taken care. So first is nature of stock item, that is fragility. And other important thing is different sizes are there. Different sizes are there. So even for the stock item, if you have one particular stock, you are not supposed to select the conveyor. We should select for in such a way that we should select for a conveyor which can adapt or which can work on multiple products. The second criterion, warehouse throughput. What is the number of items we are going to shift for one particular period of time, say per minute or per hour, whatever the nature is. Then how the movement is going to be all about, whether it is going to be completely vertical or some sort of bend you wanted to go ahead with. Why this is very essential is conveyor systems are not suitable for perpendicular joints. This has to be thoroughly understood. Conveyor system can be used for even angular case. Even we can go ahead with some sort of semi-rotation, that is semicircle based, it can rotate, or some arc based transportation is possible. But at any point of time, conveyor, a plain conveyor can never handle perpendicular movement. But still it can be made. We need to have a different type of pushing based conveyor, but that is not advisable for a fragile product. So we should understand the movement of the or the direction of the transport or traverse. The next very important thing is the distance how much it is going to travel. Why? Because for a belt case we can't have a longer distance. Again, we should have some sort of support, so distance has to be considered. Then the third, long-term goals. Why long-term goals? Means at any point of time we are prone to development, and that is the essence. We should develop with respect to time. So now we have installed one set of conveyor system, and in a future, say after some few years, it should be profitable. Means it is supposed to be reconfigured. Whatever the configuration right now we have got, that should be reconfigurable so that it can be developed. For example, today we are going with type 1 of conveyor. Maybe after some few years that product would have got obsolete, or we would have upgraded to some other product. Now the same conveyor system should be reconfigurable from type 1 to type 2. So that is how that future sense should have been thought of. Now these many types of conveyors are there. So based on this only we need to select. So now we'll go one by one. So starts from belt conveyor, roller conveyor, slate or apron conveyor, chain conveyor, chute conveyor, ball transfer conveyor, overhead conveyor, pneumatic vacuum conveyor, bucket conveyor, magnetic conveyor, wheel conveyor, walking beam conveyor. So don't get don't get panicked by seeing different number of conveyors. See, each and every conveyor is having its own uniqueness. This is what we need to understand. In simple, let me give a very simple example. We have got a plate full of fried rice. As well, you have got a plate full of noodles. Now, there are two options to handle this food particle. The first one is you have got a spoon, and the second one is you have got a fork. Now, again, spoon, there are different types of spoons are there. Hope you guys might have a knowledge in this. Say teaspoon or a tablespoon, or for the case of soup, we have got some other type of ladle like thing, that is another spoon. Let us take for the case of simple example. Which one will we prefer? So this is what the nature is. For a fried rice, it is very obvious that we are supposed to go for a spoon, because fork will not work for it. Similarly, for a noodles, spoon will not work out. Only fork will work out. So likewise, based on the nature, not of the food, with respect to the product, we are supposed to select the conveyor. So the construction wise, it's going to be very simple. So there are going to be figures for each and every conveyor system. So you can correlate with respect to the functionality along with the figure. So therefore it makes a clear comprehensive sense. So that's where it is easy for you to learn. Belt conveyor. A belt conveyor is one most common. Any warehouse, when you are going to start with the process, the first foremost solution what we land is belt conveyor. Why? Because simple in construction, simple to design, simple to manufacture, as well simple to install. So owing to these many attributes, so belt conveyor are the very simple. So distance, it is going to be different. So length is going to be different, width is going to be different. So whatever the nature we wanted to go ahead with, yes, it can be easily fabricated and installed. We'll see the design, cross-sectional design. So this is, so this particular part, what you see, it's very simple, right? So it's a simple table, a platform and an elevated platform. We have got a motor, and one end is going to be the driver and the other end is going to be driven, and in between you have got a belt, a completely closed belt, which is having some amount of tension. Why? Because if you are not having sufficient tension, there will be slack. Now comes another doubt. If you tension the belt, that is, if you provide some sort of pulling force, what happens is it is prone for some sort of damage over a period of time. Not at day one, but over a period of time, yes, it is susceptible for some sort of damage. So that is how we go ahead with some different supporting idlers. We can go with idler mechanism. So therefore a slag can never be experienced in a conveyor. And other thing is, we have got a completely rolling one. So it is not going to be idle, it is going to be rolling. So let us understand the cross section. So the cross section are like this. First, we have got a tail pulley and the head pulley. So head means it is the one which is going to drive. Okay, so this is the driver, and the tail pulley is the driven. It is the driven part. So in between we have got several idlers. They are idlers. So you can adjust the position. So from top to bottom or bottom to top likewise, but not to a greater extent. Maximum by an inch. Maximum by an inch we can go ahead with. So this is how the simplest construction. Only thing is we need to have platform. And now this platforms even can be adjustable from top to bottom. Even then it is possible to adjust. Second, roller conveyor. So the first half was with respect to a belt conveyor. Now the roller conveyor. So roller conveyor is very simple. It is going to have circular tubes. So earlier case, there was a driver, there was a driven, and in between we had idlers, and this belt material was sufficiently tensioned by means of this adjustable idlers. But here it is not so. We are going to have circular tubes. Now circular tube means it is very simple. They are going to roll independently. No driver, no driven. From higher end it falls automatically to the lower end. For better understanding, we'll just go to the design. So here these all are the tubes. These all are the tubes, and this can be the height of the table need not to be the same. So one can be high and the other can be low by very nominal case, hardly some 1 inch or 2 inch. A small taper, a small difference in height will easily solve the purpose. These rollers are nicely free to roll. So either end we want, it can easily roll onto it. So now we'll analyze the advantage with respect to the earlier one. Earlier one was power driven. There were several idles were there, and here nothing. It's very simple. Only thing is you have the difference in height with respect to the platform. Therefore, we get the requisite amount of taper. Therefore, it is a free-fall nature. Now, what is the thing we need to define or understand here is the nature of material what we can transport. In this particular roller conveyor, is it possible for us to transport glass like material? Definitely the answer is no. This is what we need to understand. So based on the product, we need to decide upon. So that is what the first criterion to select is stock items. The next, slate or apron. So slates are very simple, chain light small platform which is linked by means of strain. So you can go for any case. You wanted to go for a vertical case. See, earlier two conveyors were fit only for horizontal, but now when you wanted to go for some angular or something with respect to vertical or horizontal or mixed hybrid, any cases it is possible. Now we'll see the design. So this is what. Okay. So how vertical means not 100% vertical, somewhere slanting. Still it is able to take up the thing. So it is as simple as this, but the problem here is it's going to be a little bit bulky. So we need to ensure that it is mounted on the floor properly. It can be employed for the case of heavy weight components. Heavy weight components, unless the previous two where you can't go for a heavy weight over with respect to a length. But here it is absolutely safe. But only thing is it should be perfectly it has to be mounted on the floor. Next, chain conveyors. So chain conveyors are usually it is used for heavy duty application. So only heavy duty, some engine block like thing where you have got a solid material that has to be transported from one point to another point, which is really bulky and it is really sturdy enough. Yes, we go for chain conveyors. So basically chains are a positive driven system where there is no slip, like belt, no slip. It is going to be properly, it is going to work, and no slack. Why? Because whenever we find some sort of slack, we can have an idler rack and that idler rack will take care. Again, this is the positive side. What is the negative side is it's going to be a little bit noisy. Why? Because the chain should engage in the gear sprocket. So it is going to be a little bit of noisier operation. Next, chute conveyors. So why we have different types of conveyors means two reasons. First reason, nature of material, and second reason is cost. So we need to think with respect to cost, because newer solutions means it should not be costly, it should also be cheap. So a chute conveyor is the simplest and cheapest form of transport system in a warehouse industry. An inclined chute transfers items from a higher level to a lower level using gravity. So this is very cheap. Rather than using the term cheap, let us use the term affordable. Okay, it is very affordable and it is very easy to use. Power free operation. That's how we can summarize it. So it is something like a slide where kids play in a park. It is very simple, nothing, but only thing is the stock item, that is the nature of product what we use should be in a position to support. That is the only thing. Something like a gunny bag or some little bit soft and delicate as you can go ahead with, but not fragile and bulky items. Think of if you just put a connecting rod or a piston, that will roll down and it will fall. Definitely accidents are going to occur. So such nature of material can be decided upon. Now this is another type. So it is a spiral type. Okay, spiral type. Earlier was simple incline and this is spiral. So based on the nature we can think of. Next, ball transfer. So ball transfer is we'll have rotating steel balls being embedded here and there. So when you wanted to go something like a sheet, a delicate sheet, a small thin sheet. So this is the only thing it is applicable. So the design is like this. So we have got an encapsulated housing which has got the steel ball. So series of a pattern and array of steel balls are located here and there. So you can use for small delicate items. Even bulkier items also we can go ahead with. But we must ensure that the ball size is capable enough to hold the surface. It should not have some holes or in between, because this ball will go and get locked into the hole. So the diameter of the ball and the diameter of the hole, what is available on the product has to be nicely thought of. Next, overhead conveyor. So the name itself tells. Earlier, what are the thing we discussed? It's going to be either on the floor or somewhere in the mid of the air, but here it is going to be completely onto the overhead. So once you don't have sufficient space on the floor to work, the only thing is volume. We need to think of the volume. So that is where overhead conveyors are suitable enough. But again, safety plays a very crucial role. So considering safety, we'll see. So this is how it goes on. So the design itself tells that for bulkier products, no, it is not suitable. So for lightweight products where you wanted to transport over a large area and you don't have floor space, yes, this can be thought of. Next, pneumatic vacuum conveyor. So this is again purely based on the stock item where you wanted to transport before packing something like cement, flour, pellets, small crystal like plastic elements are called as pellets, and sand or sawdust in food processing industry, again some crystal like sugars, something like that you wanted to go ahead with. So it is very easiest mechanism. So this is how it works. So there is going to be a hollow sucking tube which is connected to a compressor that sucks, and because of the velocity of the air it is going to get nicely mixed and it is going to go to the end till whatever the end we want. Theoretically speaking, it can go any nook and corner, no bend, nothing. It is not going to affect the flow of the products. But one thing what we need to go ahead with, all these products whatever we use should be free from wetness. It should be completely dry, then only it nicely mixes with air, then it goes on. If it is wet, no, this system will not work. So that's what I have been emphasizing. Based on the nature of the stock item, we shall decide upon the conveyor system. So when you get into some grain processing, so we have the grain, rice grains, right? We need to remove the shell and we polish and we get the rice. So such cases, completely it is going to be free from moisture. There is no wetness involved, completely they are dry. So these are the effective mechanisms. You can't go for any other conveyor system. Only such conveyor systems will solve the purpose. The next, bucket conveyor. So the name itself tells bucket. When you want to go for some liquid cases or when you wanted to go for some semi-solid cases. So this is going to be quite interesting. Why? Because you have got buckets, bucket shapes, containers of bucket shapes where we can go ahead with. So these are the buckets. So it can be taken on an horizontal case, vertical case, hybrid case, anywhere we can go ahead with. Because it's a container, basically it's a container. So it can transport on the larger distance in a very, very safe case. The next, magnetic conveyor. See, magnetic conveyor, the term itself tells we are going to have magnets that are attached to stationary plates. Some plates are there on which you can go ahead with the magnets. So what happens, any magnetic particle, it is going to come and it is going to get stuck. It is going to stuck onto the platform, then we can go ahead with. At the end where we wanted to unload, we can demagnetize. So such a ferromagnetic material, dimagnetic material will be the magnets being made out of it. When current is passed, it becomes magnet. When the current is taken back, it is going to be non-magnet. So likewise, loading and unloading can occur within one particular case. So usually it is used for metal scraps. I'll tell you one example. So when you have got furnace is going to work on a high temperature case. So this metal scrap has to be unloaded into the furnace. So manually you can't load. Why? Because furnace will be in the temperature of 2000 degrees Celsius or more, even more than it. So manually, or even you can't think of robots or any cases, but such magnetic conveyors will solve the purpose. This is one simple example. So we'll see the design. So this is all. Okay. Small delicate particles you can use, but again the counterpart, that is disadvantage, is non-magnetic material can never be thought of. You can't even think of processing them. Next, wheel conveyor. So A metal frame connects a set of wheels and allows for the manual rolling of items placed on top of it. Wheel conveyors are affordable and easy to operate, and people commonly use them in reception and dispatch areas. Okay, so it is very simple in construction, we'll see. So this is a series of rollers are provided onto the shaft. So this is very simple. It is a modified form of roller conveyor. Roller means it was a complete cylinder. It was complete cylinder all across the width of the conveyor right from starting till end. But now it has been made into a small wheels. Small wheels. What is the purpose is we are minimizing the contact area. On the roller conveyor, complete line contact comes into picture. All along the length of the periphery of the conveyor, the rollers are going to be having a contact with the workpiece. That is the product. But here it is no, only restricted, only certain points it is going to work out. So therefore we can minimize. So nature of wheels, what we use? If you use polyurethane rubber, we can use especially in the final case. Why? Because it is not going to damage, because it is made out of rubber material that is not going to damage the workpiece at any point of time. Okay, some cases we wanted to go with even silicon material. Yes, it is possible. So usually wheel conveyors are used in the final dispatch case. Even cardboard can be nicely transported onto it. And the final type, walking beam conveyor. So usually like static and moving supports to transport pieces sequentially, one after the other. The walking beam conveyor is suitable when the warehouse manager needs to ensure equal spacing between transported items. We'll see the design, then you will be able to understand as well. I'll explain. So this is what. So walking beam means side you will have two slots. So you can see there are two slots are there, and these all are the slots which will take up. It's a small fixture like thing. Based on the workpiece we can have uniform gap, the pitch. Okay, the uniform gap can be ensured among these two consecutive teeth like structure. So among this tooth you can place the component. It can be anything, it can be cylindrical or anything. So usually it is used in two cases. Case number one, once you wanted to machine, so the operator should load and unload. So at some prescribed distance or prescribed time within that particular gap, if they get the part, that is sufficient. Means under those cases we go for walking beam. Or other cases in painting, so some exposure is necessary for the part, okay, for a prolonged time. So you can adjust the pitch and therefore we can design upon. So to summarize, we are in the discussion of physical process automation. So in this presentation we discussed about the conveyors. So the necessity for conveyors, how simple are they, and based on what criteria do we select a conveyor was thoroughly discussed in this regard with respect to the 12 types versus the design, and the nature as well as the difference with respect to the conveyors was discussed. So dear learners, dear students, any doubts kindly note it down. So during our offline class we shall discuss the doubts. So thank you one and all. Thank you.